Hello there. My name is Rishi, and my project is about accessible spatial audio interfaces. Most content and services on the internet are designed for visual access and consumption. Persons with visual impairments often make use of screen readers to access the same information. Screen readers are only aware of the syntactic structure of the web page and convey this information through a single stream of computer-synthesized speech. This can make browsing quite slow and cumbersome, and also makes it difficult to understand additional information encoded in layouts. But what if screen readers could provide visually impaired users with more auditory information and more information through audio? While these two phrases may sound similar, they represent two different ideas that we explored in this project, which are the use of concurrent speech and spatial audio. Concurrent speech is the idea of presenting more speech information simultaneously, but from different directions in space. We developed a prototype screen reader that could present news headlines concurrently. We leverage the human ability to focus on a relevant source of information, even when there are many parallel streams of audio being heard at the same time. Spatial audio can also be used to present more information through audio by conveying layouts. We mapped the visual position of elements on a screen to auditory positions around a user, and implemented prototypes of an auditory torch, an interaction method that allows for both focus and context. We then conducted a pilot study to see how these two ideas performed. We asked participants to search for specific headlines in a list while listening to them individually, where the speaker was in front of the listener, in pairs, where the speakers were located to the left and to the right, and in triplets, where speakers were at the left, right, and front. The voices used in all of these positions were either all the same or all different. We also asked participants to search for the same specific headlines while making use of the auditory torch prototypes. We came away with three major findings. First, we discovered that participants had different listening strategies when it came to comprehending concurrent speech. While some users tried to listen to all the streams simultaneously in search of the relevant headline, others listened to them sequentially by tuning out of all but one stream. Second, there was a differential effect of screen reader voices across participants. We found that participants perceived the synthesized voices not as same or different, but rather as familiar or unfamiliar, something that we would have to account for in future studies. Finally, this pilot made the importance of grounding research in real use cases all the more evident. Participants were mostly unconvinced about the usefulness of concurrent speech in itself. However, it made more sense to them to compare concurrent speech with the common method of listening to synthesized speech at faster speeds. The torch prototypes were better received by the participants, and they expressed interest in testing out more developed versions of the same. To conclude, this pilot study helped us gain an initial understanding of how people might use spatial sound and concurrent speech in auditory interfaces. In the time since, we have been developing more full-fledged prototypes of the auditory torch, and we hope to deploy them in the near future. That's all that I have for today. Thank you for listening.